Hello, Dr. Perlman. Thank you very much for joining us today. My name is Jessie Wu, and I'm a reporter with CW Media. We're currently conducting an interview series called The History of the Internet, speaking with people who played key roles in the Internet's early development. We're very grateful that you've agreed to share your experiences with us, and I'm really looking forward to our conversation today. Thank you for being here. So your work has often focused on making networks behave well at scale. When you look at today's internet, what aspects still surprise you, either positively or negatively, from a system behavior perspective?
Well, I don't think anyone envisioned it being as big as it is today, as influential in sometimes extremely bad ways as it is today. For instance, you can spread whatever misinformation you want. You can get people radicalized because if there's like 50 people across the world that believe some silly thing, they're not that much a threat. But if they can all find each other across the internet, then it becomes very scary. There's other things that are just miraculous to me, like Wikipedia. If you just look at the comments section on any social media thing or any news thing, it quickly degrades into just insults and whatever, probably enhanced by bots that are purposely trying to sow discord and hate. But Wikipedia, for some reason, it's just too large for anyone to really monitor what's going on, but it seems to be one of the best sources for concise, accurate reporting on things. So how on earth does that work? Another thing is something like eBay. It should just be full of scammers, but it does seem like you search for some bizarre little thing and it's from some merchant you never heard of, and you send money and you get the thing. It's just kind of amazing to me.
Hey, so how did you get into designing network protocols?
Well, that was just complete randomness. It wasn't like I always wanted to do that. When I was in graduate school in math, I knew how to take classes. So I had done everything that I needed to do except a thesis. But then it was my responsibility to find an advisor. A few months after that, when an old friend said, "Are you enjoying grad school?" And I said, "No, I'm floundering now because I have no idea how to find an advisor and start on a thesis." He said, "Oh, come join our group." So at that point, I dropped out of grad school, and his group was designing the packet radio network. And a few years later, I got like the ideal job at the ideal time and place, which was designing how routing works for commercial networks. So before that, people had designed networks, but it was largely small researchy things. And so I was designing and I got to be really influential as well, because back then I didn't have to fight with standards bodies or anything. It was my job. And so whatever I designed just got implemented. And, things still work the way I designed it back then. I did 10 years later decide to go back to grad school, and I did finish my PhD because at that point I didn't really need an advisor. I knew enough about networking to just be independent.
So another aspect of your work is robustness. What does that mean?
Well, robustness can mean a lot of things. They were all managed from one place. Work did not work. You went to the one router that was where you managed the networks from, and you sent messages across the network to diagnose what was going on and to fix what was going on. Well, that doesn't work if the network is broken. So my first paper was sort of looking at the existing network, which was the ARPANET, and noticing that a few corrupted messages and the network would never recover. And that actually occurred after I published that paper, which was really cool. So my first paper was, hey, a network has to be much more robust than a single computer. So with your PC, it always does weird things or whatever. So you reboot it and everything's fixed. But with a network, it can have problems, and the ARPANET problem rebooted one by one all of the routers. Did messages would come back and infect them. No way to fix it with their algorithms. So the paper basically said it has to be what I called self-stabilizing, meaning once you get rid of whichever computer is corrupting messages, once you disconnect it from the network, then the network should be able to return to normal operation by itself. And when I went back to grad school 10 years later, my manager at Digital Equipment Corporation, who was very smart, he said, gee, in your paper, you said that in order to make the network recover, you have to find and disconnect whichever computer is corrupting messages. That's the only way to do it, or figure out some other way. So my thesis was how to make a network resilient, even if some of the routers that are in there are misbehaving. So what behaving router do? It could give false information in the distributed routing algorithm, which is the algorithm is where everyone gossips based on what they know locally, compute based on that information. Or a sick guy, it doesn't have to be actively malicious, can give false information in that. Or it could flood the network with garbage so that the good traffic doesn't get through. There could be a router someplace that's doing everything perfectly, but it doesn't like a particular source way over there. And whenever it sees that source's packets, it throws those away. So I wanted to achieve in the thesis was assuming there's at least one honest path connecting this guy and that guy. They should be able to communicate with a fair share of bandwidth, even if every router other than the one honest path is arbitrarily malicious. And I've never done anything difficult. If you look at things from just the right angle, you can see how to solve it. And so I looked at it from just the right angle and I realized, oh my goodness, it's quite simple. So then I was afraid I wouldn't get a PhD for it. So I asked a professor, is there any minimum length to a thesis? And he said, well, it either has to be long or good. That's another example of resilience, which is even stronger than in my first paper. But yet another thing is making it work with people. So it's easy for engineers to say, well, that's bad users. They're configuring things incorrectly. Well, you should make your stuff not be so fragile that you should never blame people. You should realize that your system is not designed well if people can accidentally make things broken.
Well, that's really cool. So the string protocol solved a very practical but crucial problem in early networks. Do you think modern networking still prioritizes simplicity and correctness to the same extent?
Oh, absolutely. They do not encourage simplicity. These days, there's standards bodies, which is like a whole bunch of people. They also don't start out with the principle that I think is so important, which is know what problem you're solving before you try to solve it. So they start with all these buzzwords that nobody really understands, like zero trust, which doesn't actually mean anything, but it's a big buzzword today. They don't really know what they're doing, and they just want to be, oh, it'll be so exciting if we're one of the authors of some standard, and they just start doing something. And then it turns out they're not really doing a good problem. So they just sort of make it more and more complicated. And you get this mess afterwards that is sort of astonishing that anything works these days.
Okay, I got it. Over the years, the internet has evolved from a research network into crucial global infrastructure. What responsibilities do engineers have when the system they design became socially indispensable?
Well, that's a really hard one. If it were just kind of exchanging information, what possible responsibility could they have? You could always have encryption, cryptography. The network The worst it can do is not deliver your data or mangle it, but then the receiver would know that it was not the correct thing. But these days, you're getting information from people you never heard of. Um, News used to be the Channel 4 news team on site, and you could trust them. They were sort of well known. But these days, it's a teenager with a cell phone that records some sort of important event. Even if you know that it is what the teenager uploaded, well, whoever's in charge of the internet, and it's not like anyone is in charge of the internet, should be responsible for making sure that private information is kept private, that things that are claimed to be news are always true. But I don't see any way that this can happen. So it is kind of terrifying.
I think so. You have a strong advocate for security that is designed in, not bolted on. Why is this principle still so difficult to implement in practice?
Well, it's not clear what security means. So, again, to first start out with knowing what problem you're solving. So, if you just say security is good, everyone agrees with that. But what are you talking about with security? Are you talking about making sure that you can receive data or that the data that you receive is true? Then it becomes really much harder. So I do believe that there should be a lower level that just moves data around. And then on top of that, and you might think that's bolted on, you have cryptography and authentication. So that all sounds great if I want to send you an email that you'll know that it came from me and ahead of time who I am. That model kind of falls apart when you're getting information from people you don't know because there's no way for them to authenticate themselves to you. You don't know who it is that you're supposed to be authenticating. And even for things that we pretty much have figured out, how to talk to a website securely. So to some website, Amazon.com, all this cryptography with certificates, sends you a certificate signed by something that your browser trusts that says that it really has the name Amazon.com. And you do all this wonderful crypto and protocols, and then that you're talking to Amazon.com. Well, the problem is that I got caught in a scam. I wanted to renew my license. I'm a human. I don't know the right URL to get my Washington state license. So I did a Google search, and the top thing, you get this ridiculous URL that no human should ever see. But I do understand URLs. And the name in there was something perfectly reasonable, something like WashingtonLicensing.org. And the website looked perfectly reasonable. It gave me the choice of replacing a lost license or renewing my license. I clicked on renew, and it asked me everything I expected it to ask, which was what's my license number, what's my address, what's my credit card number, and success. I thought I wouldn't have thought anything of it in a month or two when I didn't receive my new license. But the bank fraud department called me because the criminals that put up that website were too greedy and they kept charging more and more. But it's a great example where, despite all of these standards and fancy math and all that, there is actually zero security because it assumes the human knows the right DNS name to go to. And there's absolutely no reason to believe that. I've told this story. Some people said it should have been a .gov URL, not a .org. As no, why should I know that? I'm a human. It is actually terrifying, and we don't have as much security as we think we do. And it's not due to weird weaknesses in the particular math of the cryptography. It's due to basic assumptions like assuming, well, the human will know the right DNS name.
Hey, I got it. Many proposals today advocate decentralization as a solution to trust and control issues. Where do you think decentralization genuinely helps, and where might it introduce new problems?
Right. So I love this question. People just kind of mindlessly have assumed centralization is bad. And this is all sort of comes out of blockchain. But centralization is going to be a lot more efficient because there's sort of one place. So you might think, well, that one place can do immense amount of harm. Well, if you have multiple centralized of something, then you can make something arbitrarily robust without any of the complexity of making it distributed. An example of this, credit rating bureaus. So there isn't some organization that decides which other organizations can be in a magic consortium of credit rating bureaus that trade information and agree on credit rating scores. No, anyone can be a credit rating bureau, and they have their own algorithms for how they get information and how they compute scores. If a landlord wants to find out what your credit rating is, they can ask any of the credit rating bureaus that they trust, or they can ask several of them and see if all of them pretty much agree. But if you do this kind of thing where you have, 20 entities that all have to be exchanging information, it's going to be, much less efficient. So for instance, Bitcoin is unbelievably expensive. They try to come up with other instances of blockchain that won't be as expensive in terms of energy consumption. It's just not a good solution, certainly not to any problems that really you just want a database for. So another thing about centralization is if you buy something through eBay, for instance, then if the merchant doesn't ship, they make the merchant ship it to you, or they give you your money back or something. If you use Bitcoin, hiring a hitman or something, if you pay someone to kill somebody and they don't kill them, who do you complain to get your money back? So it's nice to have some central organization for being the adult in charge of these things. So I have a lot of different talks about things that people claim, for instance, blockchain would be good for. And I explain for all of them why it actually would not be good, and some other solution that would be so much more efficient and robust.
And that's our last question. Network security has been a major focus of your work. What do you see as the most fundamental security challenges that still aren't solved elegantly at protocol level?
Well, that is very difficult. It's all the stuff that's so incredibly important. How do you know what information is true? And then when you have non-technical politicians that make laws, that's also really scary. You're allowed to tell the internet to make sure that there's no pictures of your kids posted. How can anyone possibly do that? If people don't actually tag your kids, are they supposed to do facial recognition on every single photo that's up there or something? And how do you ever get rid of things that are posted? It's extremely difficult to do that. The internet is really bad. If there's some group of people that hates some other group of people, they can post where you live and where your kids go to school, and there'll be enough nuts in the world to, make your life very, very dangerous. I don't know how to solve that. There's so many ways of scamming people, where there's people that believe that they're in love with somebody, beautiful woman living in Idaho, but it's instead someone living in Nigeria, and they keep sending them more and more money. These are all very sad. And of course, the spreading of misinformation. So if you want to have everyone hate left-handed people, you just talk about all of the crimes that are being done by left-handed people, and left-handed people are stupid and evil and whatever. And enough people are going to believe it, especially when they get told that so many times. So I do worry that the internet is kind of the end of civilization. I don't know what to do about it. But on the other hand, I'm ready to retire. And there's all these young people that want to be able to do exciting things. Tell you, we have developed the internet and everything about it is perfect. Enjoy. You wouldn't have anything to do. Isn't it so much better that we say there's all these incredibly difficult problems that you can work on?
And Dr. Perlman, thank you so much for spending this time with us today. It has been truly wonderful to hear your perspective. Your work has had a lasting impact on the internet and on generations of engineers, and it means a great deal to us to be able to share your insights with our audience. Thank you again for joining us. It has been a really pleasure speaking with you.
Right. Likewise. Thank you so much.
Okay, bye bye.
Bye bye.